Now, as we examine our circuit in the final conditions, we know that it has been like this for a quote-unquote long time. So we can replace our inductor with a short circuit, and we can replace our capacitor with an open circuit. And for our time infinity conditions, the things that we care about the most at the moment are the current through wherever that inductor used to be, and then the voltage across the capacitor where it is now an open circuit. So going to find the current through the inductor, if we treat this as two different meshes, this could be mesh 1 and then mesh 2. We can now know that IL is the difference between the I1 current and the I2 current. And now I can write out an expression for my I1 mesh by saying negative 24 plus 2I1 plus 4I1 minus I2 plus 6I1. Now that I2 current right there, that is directly connected to a 4 amp source because that is the only branch current over there. And so I can just replace I2 with 4 amps. Once we plug everything in, we can now find that I1 is equal to 3¼ amps. But I1 is not the quantity that we're after. We're actually after IL, which is, because it's a mesh current between the two meshes, is I1 minus I2. So this is going to end up being 3⅓ minus 4, which makes IL negative 2/3 amps. And so up here I'm going to write negative 2/3 amps for our I1 current, or IL current. Finally, for the voltage across our capacitor, we can perform simple analysis by saying the voltage across this capacitor is equal to the voltage drop across this 6 ohm resistor. And we know that that is equal to the current times 6. And we already know the current that is in that branch because it's 3⅓ amp times 6 ohms gives us 20 volts. So our final conditions here for the capacitor are 20 volts and negative 2/3 amps across our inductor. Restarting this slide in 3, 2, 1. Now we can finally return to our table of initial and final conditions and find out that across our capacitor in the final setting it is 20 volts, and our current through the inductor in the final setting is negative 2/3 amps. And so this giant table, along with the equations we're going to develop, are going to fill in all of our constants and parameters for all of our equations that we are about to finally figure out.